Hello, welcome to my YouTube channel. In this video, we're going to look into the problems for combinations and permutations. So as you remember, like we already discussed the formulas in the previous video for permutation, so which was like NPR. So this is n factorial over n minus r factorial. And for NCR, we learned the formula, it's n factorial over n minus r factorial times by r factorial. So these are combinations and this is permutations. And other than that, we learned just a counting principle. So let's see here the example for counting principle. So how many ways can the letter of the word year be arranged? So here we can see all the letters, like Y is here only one time, E is again one time, A is also one time, and R is also one time. So we can directly use counting principle. So here there are 4 letters. So 4 factorial, basically if we use the counting principle, so being choose the first letter, 4 possibilities we have, and then 3, and then 2, and then 1. So that's mean this 4 times 3 is 12, 12 times 2 is 24. Okay, so the next one, another example, in how many ways can a 10 people sit on a row of 10 chairs? So again here we can see like there is no order, so just like we need to choose the people, so they are gonna sit into row for 10 chairs. So that's mean this is technically 10 factorial, so which is 10 times 9 times 8 times 7, 6, 5, 4, 3, 2, and 1. So you can simply use a calculator for this. Using calculator, so you will be getting this as an answer for that. Okay, let's have a look at another example. So how many different 5 letters arrangement can be made using the letters in Cambridge? So here again, if you see in this letter Cambridge, so there are like 1, 2, 3, 4, 5, 6, 7, 8, and 9 letters are here, and still you can see there are no letters are repeated. So basically we are trying to make out of this, since there are 9 letters, but we are trying to make 5 out of them. So 5 arrangements. So that means this will be 9 p5. So that means this will be 9 factorial over 9 minus 4 factorial. So 9, and 9 minus 4 is 9 minus 5 is 4 factorial, so 9 times 8 times 7 times 6 times 5 times 4 factorial, so 4 factorial and 4 factorial will cancel out. So if we just calculate this, so we will get, this will be 15,120 arrangements we can make out of this letter Cambridge for 5 letter arrangements. Okay, so let's have a look at another example. A candidate in an examination has to answer 4 questions from a choice of 6 and can answer them in any order. So how many different orders can the candidate provide their answers in? So here, since we know there are 6 number of choices, and out of that he can choose 4 only. So this will be 6p4, so 6 factorial over 6 minus 4 factorial. So that means 6 times 5 times 4 times 3 times 2 factorial over 2 factorial. And if we multiply them, 6 times 5 is 30, 30 times 12, so which means there can be 360 arrangements he can give. Let's have a look at this example. A group of 8 people includes 2 married couples. So there are 2 married couples and the total number of people are 8. In how many ways can they be seated in a row of 8 chairs if there are no restrictions? So if there is no restriction, that's mean like we can use the counting principle, so it can be 8 factorial, so which is 8 times 6 times 7 times, sorry, 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, and if you calculate this, so this will be 40,320. Now be part of it. The married couples each sit beside their partner. So since we know there are like 2 married couples, and in a couple so there are 2 people, so it's 2 times 2. The married couple are gonna sit, and then for the rest of them, because the total there are 8 people, so then for the rest of them there are 6 factorial. So 6 factorial times 2 times 2. So if we simplify this, so this will be 2880, because here since we're gonna consider as a 6 subjects other than married couple, so then like we know in each couple there are 2 people, so there are 2 couples, so 2 times 2 times by 6 factorial, and this will give us the answer as 2880.